Welcome back, scholars, to our final lesson for this unit. We're going to be focusing very briefly on functions and their inverses. So today we're going to find the inverse of a linear function given in function notation so that you can write a linear function and an inverse function to model data and solve problems. And I'll know I've got it when I can use words and equations to describe the inverse function given any context. So let's jump into it. An American traveler who was heading to Mexico exchanges some US dollars for Mexican pesos. At the time of his travel, $1 can be exchanged for 20.54 pesos. Find the amount of money in pesos that the American traveler would get if he exchanged $100. So this should be rather intuitive, right? If $1 is worth 20.54 pesos, then $100 would be worth the multiplication. So we know that would be 2,054 pesos. I'll let you handle $500, but write an equation that gives the amount of money in pesos P as a function of the dollar D being exchanged. Whatever the dollar amount, we will be multiplying that value by D. So we can leave our equation as such. The reason why I started off the activity is because now we are going to apply the opposite process. Mexican businesswoman is in the United States, is exchanging some Mexican pesos for US dollars at the same exchange rate. So how much American money would she receive if she was handing in 1,000 or 5,000 pesos? And I'd like for you to create a function that reverses that process. Which brings me to our first vocab word, or only vocab word for this lesson, the inverse of a function. Is a rule that acts on the output of the function and produces the corresponding input. Case in point, right? Our output here is the peso value, the input, the dollar. The inverse of the function would be the dollar value with the input being the peso amount. Right? So we are unwinding or reversing mathematically the behavior of a function. So an inverse undoes or reverses what the function has done. Some quick notation real quick. Okay, you'll see an inverse is written as this. There we go. Brackets to hold that bad boy. Right, it is not f to the negative 1 x. That does not mean 1 over f of x. Okay, this is the inverse of f. Okay, we use that negative 1 to symbolize, and it's attached to the function to infer, to communicate, to convey that we have the inverse of a function. So in general, I'd like for you to brainstorm real quick how we could algebraically check if two functions are inverses. What do you think must be true between the two of them? So over the next two slides, you're going to be dealing with water in a tank. How is the water in the tank changing? Be as specific as possible. What does WT represent? Is WT the input, the output? These are conversations that we were having today during our transformations lesson. Sketch a graph for the function. Okay. I provide you with another tank water situation and ask you a few more additional questions. The main one being the information and what the actual inverse of function W is. Which brings me to our final point, the inverse function property. So a few slides before, I asked you to brainstorm, how do you think we could possibly determine if two functions were inverses of one another? That property states that if you take the composition, so we take inverse composed with the original function, right? So we input the inverse function into the other function, vice versa. Our corresponding output should be x, and coincidentally, if we compose the inverse with the original function, we should also receive the corresponding output. Any function, say any inverse function, oops, any function, sorry, that satisfies these two parameters be defined as the inverse function of fx. Okay, so nice and light, nothing really too deep here. And then real quick, demonstrate that f of x equals x to the third and f of x equals x to the 1/3 are inverses of one another. And boom, that's where we will pause and pick up together in class.